Today's start the new lesson number first, level set and graphs. So our new topic is level sets. So here we consider the level set and the graph of a function f defined from u to r, where u is a subset of Rn plus 1 and the definition are the level set. It means the let f from u to r, where u is a subset of Rn plus 1 be a function. The sets f inverse of c, which is the set of all x1 x2 up to xn plus 1, which is belongs to u, such that f of x1 x2 up to xn plus 1, which is equals to c, which is called as the level set of f, where c is any real number and the number of c is called the height of the level set, and f inverse of c is called the level set at height c. That is, the level set of a function f inverse of c is the solution set of function f of x1 up to xn plus 1, which is equals to c. That is, we have a function f from u to r, where u is a subset of Rn plus 1. So then the level set of function f means it is the solution of the set of equation f of x1 x2 up to xn plus 1, which is equals to c. That means the solution set means the n tuples of x1 x2 up to xn plus 1, such that it satisfies the equation f of x1 x2 up to xn plus 1, which is equals to c. This is the level set of f. So f inverse of c, which is the set of x1 x2 up to xn plus 1, such that f of x1 x2 up to xn plus 1 equals to c. The level set is denoted by f inverse of c, for c is any real number and it is the set of all x1 x2 up to xn plus 1, such that the function f of x1 x2 up to xn plus 1, which is equals to c. We consider a simple case. So f from u to r, this is the function of f from u to r. So the set of u, which is a subset of Rn plus 1, so we take n equals to 0. So u is a subset of r, u is a subset of r. Then the level set means we define a function f of x equals to sum x square. Then the level set means f inverse of c, which is equals to the set of all x1, such that f of x1 equals to c is the set of all x1, such that the x1 square equals to c. That is the set of all x1 such that x1 equals to plus or minus square root of c. This is the all f inverse of c. We take f inverse of c, then we take in c equals to 0, so we get f inverse of 0 equals to under root of 0, that means a singleton 0. Now next we take c equals to 1, that is the f inverse of 1, which is equals to the new set. We get a new set minus 1 and plus 1. So these two points are the label sets. That is the label set. It means a collection of points that satisfying an equation f of x1, x2 up to xn plus 1, which is equals to a constant or a real number. That is a label set. Label set, it means a solution set of equation f of x1, x2 up to xn plus 1, which is equals to c. That is a collection of set of curves such that all the curve in that family satisfying n equation or of particular equation, and when we take a different values for c, we get a different curve in that family and they have some common properties. That is, we can understand the label that set. From the label set, we can understand the common properties of that family of curve. For example, consider a function f from Rn plus 1 to R defined by f of x1, x2 up to xn plus 1, which is equals to x1 square plus x2 square plus up to xn plus 1 square, and the c which is belongs to the R, that is the c is any a real number. So now we have to sketch the label set and the graph for c equals to 0, 1 and 2, and again consider n equals to 0, 1 and 2. So we take a first case. If n equals to 0, then the function f from R to R, so the definition becomes the function of f of x1 equals to x1 square. This is the general definition. So here the domain in R, so only x1 is there. So f of x1 equals to x1 square. So now put in this equation the value of c. So f inverse of c equals to the set of all x1 such that f of x1 equals to c, that is the set of all x1 such that x1 square equals to c. Here is a f of x1. This is our function, our general definition function. So here we take a value of these functions. So x1 square equals to c. So that is the label set of x1 such that x1 equals to plus minus root of c. So now we have to sketch for c equals to 0, 1 and 2. So put this value for c in that equation. So f inverse of 0, which is the set of all x1 such that x1 equals to 0 equals to the singleton 0. We get a singleton 0. So now if we take c equals to 1, so we get the set of all x1 such that x1 equals to square root of 1, that is the set minus 1 and plus 1. So again we take in this function c equals to 2, that is the we get a new set, the set of all x1 such that x1 equals to plus minus square root of 2, that is equals to the set of all minus square root of 2 and plus square root of 2. So these are the level set. Then these functions sketched in the graph. So graph of the function f equals to the set of all x1, x2 such that the value of x2 equals to the function f of x1. So which is equals to the set of all x1, x2 such that x2 equals to x1 square. So sketch the label set in that values. So if we draw a line, straight line, real line, in that if we take a first point is 0, then I will take the first 2 point minus 1 and plus 1. Again I will take on that line minus square root of 2 and plus square root of 2. This is a first equation of the level set of function f inverse of 0. Again this is the point joining this f inverse of 1, that is a second level set of equation f inverse of 1, which is a second level set. So again these last values minus root 2 and plus root 2, which is connected, so which is the last one is level set, which create a level set of function f inverse of 2.